Okay, dear students, let me explain today PLL. So what is PLL? Phase locked loop. As its name suggests, it has to lock something and it should be the loop. Now what this PLL system does, it will make its output signal frequency same as that of the input signal frequency. This is the base behind this PLL. Okay. Now in this PLL, it is very important. 2 points are important. One is block diagram explanation of the PLL, and another is 3 parameters, 3 terms related with the frequency: free running frequency, capture range, and lock range. Now with respect to the block diagram, if we see the blocks of the PLL, first block is phase detector. It is as good as the comparator. It will compare the input signal frequency Fi with output signal is fed back with frequency F0. So it will compare. If these two frequencies are different, its error signal, its difference is generated. Its difference is applied to the low pass filter. Now low pass filter, its work is to remove the higher frequencies. So if any high frequency noise is present in that signal, that will be removed. Now that DC signal is, if it is having a very low amplitude, it is amplified with the amplifier and it is applied to the VCO. It is voltage controlled oscillator. Now what is the role of voltage controlled oscillator? As the name, okay, it produces oscillations and input is voltage. So depending on the voltage, it will change its frequency. Input is, if input voltage is higher, oscillations will be higher. If input DC voltage is lower, it will lower its frequency. Okay. Now for understanding of its working, how this PLL tries to make output frequency same as that of input frequency, let me first explain the concept with the help of some real-time example. Let us take one example. Suppose one of the system is there where a robot is there, the running robot is there, and that running robot tries to detect whether any person is running with him. Okay, and it will tries to track that person, and robot will try to make his speed as the same speed as that of the person. Okay, means suppose person is running at the speed of 90 km per hour, robot will also make his speed 90 km per hour. This is the system. Okay, first you have to understand this concept. Okay, in the similar way PLL also works. Now initially let us take first case. Okay, same system is there, robot is running. Now for example, I will take some of the numbers. Suppose let us consider robot is set to run at the frequency of 100 km per hour. Okay, if it is not detecting any person, if he is not tracking any person, so we can call this 100 km per hour is the free running speed of the robot. Okay, so let us try to represent it with the help of a graph. Initially no any person is there, so robot is running at the free running speed of 100 km per hour. Okay, suppose this robot is set, or this system is set ki this robot has to detect the person, or this robot will detect the person when the person runs at the speed of suppose 80 km per hour. If the person runs at the speed of 80 km per hour and that person is increasing his speed. Okay, so let us first understand when the person is running. Suppose initially person is running at the speed of 10 km per hour. The robot cannot detect that person, because imagine the picture, the robot is running at the speed of 100 km per hour and that person is running at the speed of 10 kilometer per hour, very slow speed. So means we can say that robot and person both are not in the capture range. So robot will not detect कि somebody is running with me. Okay, so to come into the range of the robot, person should increase his speed up to 80 kilometer, for example, 80 kilometer per hour. So person will increase his speed and will reach at 80 kilometer per hour. Then and then only robot will detect. Yes, now somebody is running with me. So now he starts capturing, he starts detecting, he starts tracking the person. Okay. So at what frequency, at what speed that robots has started capturing, started tracking that person? At 80 kilometer per hour. After that, if person makes his speed 90, robo will make his speed 90. Person makes his speed 100, robo makes his speed 100. Means now robo is tracking the person, robo is running with the person. Person has increased his speed 110, robo will also run with 110. Person reached at 120 kilometer per hour, robo will also reach at 120 kilometer per hour speed. Suppose person will reach up to 200 kilometer per hour speed, robo will also run with 200 kilometer per hour speed. But what will happen? Person will again increase his speed at 210, 220 kilometer per hour, but robo has set some limitations. कि maximum up to what speed he can run. So, for example, robo has set कि he can run up to only 200 kilometer per hour. So, robo will run up to 200 kilometer per hour. Up to this point, speed of the person and speed of the robo both are same, equal. From this point to this point, speed of the person and speed of the robot are same. Now what will happen? Person is running at 210 km per hour, but robo can't. So what robo will do now? Robo will run at its own free running speed, that is 100 km per hour. Means what now? Track has been lost. है ना? Track in between robo and person has been lost now. Okay, so this is the one case if person is increasing his speed. Now second case. Now let us see second case, that is when person is initially running at very high speed, that is 250 km for example. Now again, if the person is decreasing his speed 250, 220, 200 km per hour, but robo can't detect because robo is running at 100 km per hour. So again limit has been set कि when the person is decreasing its speed, that robo can detect the person is running at 120 km per hour speed. So means what? When person reaches at 120 km per hour speed, then robo will detect कि yes, somebody is running with me. Then what robo will do? Robo will make his speed equal to 120, same as that of person. Again, person decreases his speed. Robo also decreases his speed. He will come at 100. Robo will also come at 100. Person will come at 80. Robo will also come at 80. Person will come at 50. Robo will also come at 50. Again, speed is decreasing. Again, how much speed that robo can decrease? That is also having some limit. So, for example, robo can track the person up to 50 km per hour. Again, person is decreasing his speed. If suppose person's speed becomes 30 km per hour, but now robo can't track because robot's minimum speed is set at 50 km per hour. So if person is running at 30 km per hour now, robo will move to its free running speed, that is at 100 km per hour. Okay, so these two things you have to understand first, while increasing the speed, while decreasing the speed. So once again I will explain. While increasing the speed, what has happened? At robo had started capturing that person at 80 and and after that 80 we can say that both are in lock. Person and robot are moving together, so both are locked, we can say. And after 200 km per hour, robo and person have lost their lock. Okay, and while decreasing the speed, initially person has to come in the range of the robo. That range is 120, and after 120 both are moving in the same speed, both are moving in the lock, we can say. And after 50, below 50, robo has lost the lock, है ना? So now what we have to do, we have to combine these two graphs together. Okay, so in the first case, while increasing the speed, it has started detecting at 80. While decreasing the speed, robo has started detecting at 120. So to 80 to 120, this range is called as capture range. Then while increasing the speed, robo has maintained the lock up to 200. While decreasing the speed, robo has maintained the lock up to 50. And this is called as 50 to 200 is called as lock range. Okay, same concept is also applicable to the PLL. Okay, similar background we have to keep in mind, and we have to now understand PLL. Now what this PLL is again doing? Yes, the system is same as that of your robot, and whatever the input signal we are applying, input signal to this phase detector is nothing but the person. So this robo, this PLL tries to maintain its output frequency same as that of input frequency. Okay, so initially when no any input signal is applied, means when no any person is present, what will be the frequency of the output? Frequency of the output, that is called as free running frequency. Means this voltage controlled oscillator will generate some frequency, some signal with the frequency, that is called as free running frequency. Okay, F0 is free running frequency. Again we will take some values so that it will be easier to understand. Suppose free running frequency is 10 kilohertz. Now if we are applying the input signal with frequency Fi, initially suppose it is 1 kilohertz, Fi is 1 kilohertz. The system is set to capture or to start tracking the input signal. Suppose let us consider at 8 kilohertz. So even if input signal is 2 kilohertz, 3 kilohertz, 5 kilohertz, this VCO frequency will be at 10 kilohertz, because this will not detect the input signal. So when it will start detecting the input signal, when the input signal becomes 8 kilohertz. So as soon as input signal becomes 8 kilohertz, what the system will do? The system will try to make its output frequency F0, which is equal to Fin. So Fi is now 8 kilohertz, Fout will be 8 kilohertz. Next, input signal frequency is increasing. So Fi is becoming 9 kilohertz, Fout will also become 9 kilohertz. Fin is 10, Fout will be 10. Fin is 11, Fout will be 11. Means what is happening now? The system is tracking the input signal. We can say that system is tracking the input signal. Both are running at the same speed. Then 12, input signal is 12K. Yes, output signal is also 12 kilohertz. 13 kilohertz, 13 kilohertz. Both are running at the same frequency. So, up to which frequency the same thing will happen? Both will run together. Suppose for example, the system is set ki up to 20 kilohertz. Input signal frequency is 20 kilohertz. So, the output frequency also will become 20 kilohertz. Input signal frequency is suppose 20 kilohertz, 21 kilohertz. But now VCO will lose its functioning. Means VCO not functioning, VCO will lose its tracking, we can say. Means what will happen up to this point? It will track, VCO will track, PLL will track the input. But after 20 kilohertz, input signal is increasing. But PLL can't track, and PLL or VCO will produce its output frequency, which is equal to 10 kilohertz free running frequency. So PLL started capturing the signal at 8 kilohertz, and after 8 kilohertz both the signals are having same frequencies. We can say that both are now locked. Up to what frequency this lock is maintained? Up to 20 kilohertz the lock is maintained. And after 20 kilohertz lock has been lost. Now let us explain it while decreasing frequencies. Now initially VCO is running at free running frequency 10 kilohertz, but if the applied input signal is having suppose 30 kilohertz frequency, PLL can't track. Okay. Now input signal frequency is decreasing. It has become 20 kilohertz. No any tracking is there. Now input signal is decreasing 15 up to 12K. Suppose input signal is at 12K and output signal is also 12K. So this is the specific frequency 12K where F out PLL output has become same as that of input frequency. Means now input signal is in capture range of the PLL. Means we can say that now PLL has started tracking the input signal. Now if input signal is decreased its frequency 11K, output frequency will be 11K. Input signal frequency is 10K, output will also become 10K. Input become 9K, output will also become 9K. Means now both are running at the same frequency. Means we can say that both are now locked. Input signal and output signal are now locked. Now input signal as good as input signal frequency is decreasing, F out will also go on decreasing. So again lower side limit is also there. So the PLL will track the input signal till for example 5 kilohertz. After that suppose input signal is becoming 3 kilohertz, but what will PLL will do? PLL will lost his lock because PLL can track the input signal up to 5 kilohertz. 5 kilohertz is its minimum limit to track. Okay. Now once again see, PLL started capturing the input signal frequency from 12K and both are running with same frequency up to 5K. This thing is happening while decreasing the input signal frequency. Now let us combine these two graphs together. Okay. So if we combine these two graphs together, F0 is called as free running frequency. Now while increasing the input signal frequency, input and output both are becoming same in frequency at 8 kilohertz or from 8 kilohertz, and while decreasing the frequency, PLL has started capturing the input from 12K onwards. in the downward direction. So 8 kilohertz to 12 kilohertz, this is called as capture range. Now while increasing frequency, PLL is tracking input signal up to 20 kilohertz. While decreasing frequency, PLL is tracking the input signal up to 5 kilohertz. So from 5 kilohertz to 20 kilohertz, this is called as lock range, because above this limit and below this limit, both are losing its lock. So you can explain these three terms in this way. Okay, so thank you so much. I hope you may have understood the concept how PLL is actually working. Thank you so much.